Hey, welcome back to your favorite trigonometry class. Let's continue on here taking a look at the tangent and so that we can find its inverse function. So if you think about the tangent of x, which is the sine over the cosine, we had our vertical asymptotes anywhere where the cosine was equal to 0. We know that the cosine of pi halves was 0. We also know the cosine of 3 pi halves was 0, da da da. We also know the cosine negative pi halves, 0, cosine A anyway. So we had all these vertical asymptotes. You know what, let me erase this for just a second so I have some room here. Pi halves, plus minus pi halves, plus minus 3 pi halves, and so on. And we had the sine of 0, 0 over the cosine of 0 is 1. So we have tangent of 0 being 0. Tangent of pi 4, so sine of pi 4 over the cosine of pi 4. So root 2 over 2 over root 2 over 2 is 1. And anyways, we graph a bunch of points. Look like our tangent function here. We have a period distance of pi in total. And it repeats this, right? Here's our tangent function. Well, this is a function, but again, it has the problem of not being one-to-one. And mathematicians said, well, let's go ahead and let's restrict this between, like the sine function, let's restrict it between negative pi halves and pi halves. So we restricted the domain from negative pi halves to pi halves so there'd be one-to-one, so it'd pass the horizontal line test, right? Because the horizontal line test, it was hitting these other ones, right? We were hitting it more than once there. Our range, oops, I'm sorry, that's parenthesis, negative infinity to infinity. Okay. So the inverse function would just flip these points around. So instead of a vertical asymptote at negative pi halves and x equals pi halves, we'll have a horizontal asymptote. So the inverse function, the arc tangent of x, okay, so arc tangent of x, so the inverse of the tangent, its domain will be all reals because the x's and the y's switch, right? The old range, the old set of y values becomes the new domain, the new inputs, or the set of all inputs. The old x's, negative pi halves, the old set of x's will become my new y's. So negative pi halves to pi halves. The old vertical asymptote of x equals pi halves will become a horizontal asymptote of y equals pi halves. The old vertical asymptote of x equals negative pi halves will become a horizontal asymptote y equals negative pi halves. So here's y equals negative pi halves. Here's y equals pi halves. Instead of the point pi force comma 1, it's going to be 1 comma pi force. Instead of negative pi force negative 1, it'll be negative 1 comma negative pi force. We still have 0, 0. And anyways, you could flip-flop all those points in there, and this is what you're going to see as the arctangent. So y equaling the arctangent of x. So if this is f, this is f inverse. Okay, f inverse, that's its inverse. Okay? So your domain all reals, your range from negative pi halves to pi halves, you can see it there in blue, right? There's your arctangent there. All right, let's go ahead and find the exact value of, gotta love my blue here, the arctangent of 1. So the arctangent of 1. So we go ahead like those other ones, we set equal theta. We say, well, if the arctangent of 1 equals theta, that means that I can use the inverse, tangent of theta being 1. Now remember, we cut off, or we restricted that tangent function, so I have to look between negative pi halves and pi halves on my unit circle for where my tangent is 1. In other words, what angle, the sine of what over the cosine of what will give you 1? Well, they got to be in quadrant 1, and they got the x and the y have got to be the same thing. Right? So we know it's that angle. What angle is that? Well, we know it's pi fourths, because the sine is right there, the cosine is right there. So the sine of pi fourths over the cosine of pi fourths, so root 2 over 2, the y value, x value, there it is. So the theta's got to be pi fourths. Theta's pi fourths, again, we're only looking between negative pi halves and pi halves. So that being the case, then we know the arctangent of 1 is theta. What was theta? Pi fourths. Okay. Let's do that next one there. The arctangent of, hold on, let me erase this stuff out of the way. Alright, so now we're going to set that equal to theta. We say, alright, the arctangent of negative root 3 over 3 equals theta. That means that the tangent of theta is negative root 3 over 3. Alright, so now I'm thinking to myself, okay, that means sine of some angle over cosine of some angle, when I get that, is got to simplify to be negative root 3 over 3. So you think to yourself, well, okay, and remember, theta's got to be between negative pi halves and pi halves, right? So, in fact, let me skip down to, so I'm looking at my unit circle, and I say if the arctangent, or if the tangent of theta has to be negative root 3 over 3, the sine over the cosine, then either the sine's positive or the cosine. Sine's positive and cosine's negative, or vice versa, the sine's negative, cosine's positive. Well, we're only looking between here and here. So you got to be down here somewhere where your sine's negative and your cosine's positive. So you're like, well, if it's negative root 3 over 3, maybe it's this one. Maybe it's negative pi thirds. Is it negative root 3 over 2 over 1/2? Does that simplify? Nope, that's negative root 3, so that's not it. We know it's not this one because that just gives you a negative 1. So it's got to be that one right there. We're finding an exact value, so it's got to be, boom, negative pi 6. So I know the sine of negative pi 6 over the cosine negative pi 6. This will simplify. So sine of negative pi 6, that's the 1/2. Cosine negative pi 6, that's the root 3 over 2. Simplify that. I got negative 1 over root 3. In other words, negative root 3 over 3. There it is. So it is negative pi 6 on that. Negative pi 6. Come back to this unit circle later. Where was I? So theta must be negative pi 6. Theta must be negative pi 6. So we just found theta. So we know the arctangent of negative root 3 over 3 is theta, negative pi 6. How beautiful is that? All right, so properties of inverse functions. So I think it's kind of necessary to think about, to kind of make sense of this. When you're taking a composition, if you remember f of f inverse, right, it would spit out x, right? They would, if you will, undo each other, right? They would undo each other. And the domain of f of g, so the domain, so this is a composite function, right, where that's just your inverse, okay? So the domain of f of g of x is the set of all numbers x in the domain of g for which g of x is then in the domain of f, okay? So for example, if you're running the arc sine of the sine, right, so the sine is going in, they're going to undo each other, but because this will only be true if x is between negative pi halves and pi halves. So it's the arc sine of the sine of x is just x, so they undo each other. If it's between there, because we had to restrict the arc sine, we had to restrict the sine between negative pi halves and pi halves just to find the arc sine, okay? But sine is not normally restricted. So again, it's the arc sine, and I'll give you an example here, of the sine of x is x, as long as this is true. If it's not, if x is not between there, then you're going to have to really think about it. And I'll talk about what I mean, think about it, if not. Okay? Now the sine of the arc sine of x is x, and this is fixed as long as x is less than or equal to 1, greater than or equal to negative 1. Why? Because that's your restricted domain of the arc sine. And there's nothing else you can do about it. If it's not between there, if it's not, then it's simply undefined, period. Okay, whereas this one, there might be alternates to this if it's not between there, and we'll talk about that. So let me give you an example here. So the arc sine of the sine of pi 8, so the arc sine of the sine of x is x when x is less than or equal to pi halves, greater than or equal to negative pi halves. And if it's not, then you really got to think about it here, okay? All right, so the arc sine of the sine of pi 8 will be pi 8 as long as this is true. Is pi 8 less than or equal to pi halves, greater than or equal to negative pi halves? Yes, it is. So it's just pi 8. Okay, let's do that next one. The arc sine of the sine of 5 pi 8. Okay, now we got to say, well, this will be 5 pi 8 if 5 pi 8 is in here. And we're like, no, that's not true because, this is 4 pi 8. That's the same thing as pi halves, right? That's negative 4 pi 8. So, nope, that's bigger than that. So, not in there. That's not true. Now, at this point, don't just throw it out and say it doesn't work. Because the sine of 5 pi 8 does exist. The sine of 5 pi 8 does exist. Now, it's not, and it's, here, let me show you where it's at. It's right here, right? It's 4 pi 8 plus another pi 8, right? That's where 5 pi 8 is. So like right in here is just little pi 8. So the sine of 5 pi 8, which is the y value right there, is right there. So then the question is, well, can I rewrite this? Is there an angle that's in this, between negative pi halves and pi halves that has the same y value? Has the same So right here has the exact same height. It has the same y value. I say, sure there does. So what angle would that be? Well, if this right here is pi 8 in here, then that would be pi 8. So pi halves, let me get a different pen here. So if this little angle is also, this is pi 8, which means this is pi 8. If I kind of walk it back so that their heights are the same here, right? It's the same y value. then I can go, well, what's pi halves, or 4 pi 8s, minus this pi 8s? That is the angle I need. So 4 pi 8s minus pi 8s is 3 pi 8s. 3 pi 8s. Okay? In other words, the angle that has the same sine that's between here and here, right, has the same y value as 5 pi 8s, it's right here, is 3 pi 8s. So I can rewrite this as the arc sine of the sine of 3 pi 8s. And now I have my answer. This works. And that again is because if you forget about this for a minute, the sine of 5 pi 8s exists. It's this y value. So let's find that value, but over here with an angle equivalent in quadrant 1, right? Because I have to be between negative pi halves and pi halves. And it's 3 pi 8s. And then I can use the fact that the arc sine of the sine of x is x as long as x is between negative pi halves and pi halves. Okay? Let's do another one to kind of make sense of this here. The sine of the arc sine. So now it's not arc sine of sine, it's sine arc sine. So sine of the arc sine of x is x as long as less than or equal to 1, greater than or equal to negative 1. Okay? And this is fixed. Fixed. It's got to be that. And that's because the arc sine is only defined between negative 1 and 1. Okay? So if it's outside that, I just say it's not defined. It's not like the other one. Okay? So the sine of the arc sine of a half, well, that's just a half. It's just 0.5. As long as that half, is that true? Yep, it is. So it's just a half. Let's do this one. Now I say the sine of the arc sine of negative 2.5 is negative 2.5 as long as negative 2.5 is in that interval. Well, it's not. So no good. This is not defined, period. There's nothing to think about here. Okay, there was over here because the sine of 5 pi 8, yeah, it does exist. Right? So you're finding you have to really think about that one. All right, the arc cosine of cosine of x will be x, so it will undo it, as long as it's between 0 and pi, okay, because we had to restrict the cosine, even though the cosine originally is not restricted. But again, on this one, think about it if it's not, if x is not in between 0 and pi. That's a thinker. Okay, the cosine of the arc cosine of x is x as long as x is less than or equal to 1, greater than or equal to 1. This is fixed. It's yay or nay. If it's outside that interval, it's just going to be not defined. So let's do some here. We have the arc cosine of the cosine of pi 15ths. So the arc cosine of the cosine of x is x when I'm less than or equal to pi greater than or equal to 0. Think about it if it's not. Think about it if it's not. So let's do this first one. The arc cosine of the cosine of pi 15ths. Well, that'll just be pi 15ths as long as pi 15ths. It's less than or equal to pi greater than or equal to 0. Which sure enough it is. So it's just pi 15ths. So that works. Let's do the next one. Actually, I'm going to skip down. Let me do this one here. the arc cosine of the cosine, and then I'll do B and D. The arc cosine of the cosine of negative 3 pi fourths. Well, the question is, it'll be negative 3 pi fourths as long as that's less than or equal to pi greater than or equal to 0. Well, it's not, because it can't be greater than or equal to 0. It's negative. It's negative 3 pi fourths, right? So negative 3 pi fourths, if you're thinking about on a unit circle, that's clear over here, negative 135 degrees, negative 3 pi fourths. Right? The cosine of negative 3 pi fourths, that's the x value right there, right? Cosine negative 3 pi fourths right there. So the question is, I said, well, think about it if it's not. In other words, is there an angle between 0 and pi on our unit circle? So now we're looking in here, right? That has the exact same x value. Sure enough, there it is. So I got to rotate to that angle. That's the one I want. Well, if this is negative 135, this will be positive 135. Right? In other words, it'll be positive 3 pi fourths. So we can write this as the arc cosine of the cosine of positive 3 pi fourths. Because this cosine and that cosine is the exact same thing. And then I say, oh, 3 pi fourths is greater than or equal to 0, less than or equal to pi. So it just undoes it. We're good to go. There's the 3 pi fourths on that. Okay? All right, let's do B now. And D. Alright, so the cosine of the arc cosine of x, it is, yes, it is x, as long as it's between negative 1 and 1. And remember, the arc cosine of x is restricted between there. So this is fixed. If it's not in there, there's no thinking about this. It's just undefined, okay? So let's do this one. The cosine of the arc cosine of negative 0.4, that'll undo it and give you negative 0.4 as long as negative 0.4 is between negative 1 and 1, and sure enough it is. There's no problem with that. That's greater than or equal to negative 1, but it's also less than or equal to 1, okay? How about this one? The cosine of the arc cosine of pi is pi if pi is less than or equal to 1, greater than or equal to negative 1. Well, that's not true. Pi is 3.14. So that doesn't work. So this is undefined or does not exist on that. So not defined. Let's try not defined. All right, let's keep going. So the arctangent of the tangent. The arctangent of the tangent is x. For that, now you got to think about it if it's not. And then the tangent, the arctangent of x is x for any x. No restrictions there. Okay, because the domain of the arctangent there has no problems. Okay. All right, so let's look at finding the inverse now of a function. So find the f inverse where we got 2 sine x minus 1 equals 0. Let me get my old beloved blue. You guys know I love my blue here. So y equals 2 sine of x minus 1. Now, how do you find the inverse function? If you remember from pre-calc, you got to switch your x and y. So number 1, switch x and y. And number 2, you got to solve for the new y. And that's your f inverse of x. That's your inverse. Okay, so let's solve for this new y now. Now that we've switched x and y. So I'm going to add 1 both sides. let me take it over here. So now I got x plus 1 equals 2 sine y. Let me divide both sides by 2. So I got sine of y equals x plus 1, all divided by 2. Now at this point, I'm going to undo the sign. So I'm going to go arc sine, because I know these arc sine of the sine of y, they undo each other. So that's the y, just y. And over here I've got the arc sine of x plus 1 over 2. So that's our inverse. This is our inverse. The arc sine of x plus 1 all divided by 2. Okay? Now find the range of f and the domain and range of f inverse. Okay? So let me erase this a little bit. So y equals 2 sine x minus 1. Let me talk about that one first. So first of all, here was our original, 2 sine x minus 1. First of all, the amplitude vertically stretches that up to 2 down to negative 2. But then it drops it down 1, it shifts it down 1. So instead of going up to 2 and down to negative 2, it drops it down and goes only up to 1, and down to negative 3. Okay? So up to 1 and as low as negative 3. That's the range, right? The domain is all reals, but the range, since it's been vertically stretched by a factor of 2 and dropped down 1, it goes as low as negative 3, as high as 1. So that means over here, for our inverse function, the domain will be the old range. So instead of the range, the y's, we're going from negative 3 to 1. My domain will go from negative 3 to 1. Oh, and I'm sorry, you know what? I just noticed something. This domain is restricted. I apologize. This domain is restricted between negative pi halves and pi halves originally in the problem. Usually it's all reals. This one's not, so it's restricting it, you know, between here and here kind of thing. So my range will also be restricted. Because remember, they flip-flop. Sorry about that. I just saw that. All right, let's keep going. Let's solve this equation. 12 arc sine of x. 12 arc sine of x equals 3 pi. We can divide by 12 both sides. The arc sine of x equals pi fourths. And now, how do you undo the arc sine? You run the sine on both sides. You undo it with its inverse. So the sine of the arc sine of x is just x. And here we got the sine of pi fourths. And you say, oh yeah, I know what the sine of pi fourths is. It's right here. In the unit circle. There's my sine. Whoa, my goodness, what did I just do? There's the sine of pi fourths, root 2 over 2. Okay. All right. Well, thanks you so much for listening. We will chit-chat next time. Have a good day.